Hello students, in this video we'll discuss some comprehension type question for JEE Advanced examination. So here is the one comprehension type for the JEE Advanced. So here given that the question is given that z equal to r into cos theta plus I sin theta and n is the positive quantity and z to the power 1 by n is r to the power 1 by n and cos 2k pi plus theta by n plus I sin 2k pi plus theta by n, where k equal to 0 to n minus 1 and nth root and n is the nth root of the complex number z. Okay, this is the statement of the comprehension. So let's solve three questions. Here I have given two questions and in another page there is some another question. So question number 1, what is the question? If 1 omega square up to omega to the power n minus 1 are nth root of unity. So remember one thing here, for nth root of unity, it is not the cube root of unity. For cube root of unity, omega cube equal to 1, and in this particular case, omega to the power n equal to 1. And we know everyone that for any nth root of unity, mod of omega should be always 1. And z1 and z2 are two any complex numbers, and we have to find the value. K equal to 0 to n minus 1 summation mod of omega, z plus omega to the power k z2 whole square. We have to find this value. So let's start solving this sum. Let's write this k equal to 0 to n minus 1. Here z1 plus omega to the power k z2 into z1 bar plus omega bar to the power k into z2 bar, because mod z square equal to z into z bar. Let us make mod z square, as we know that mod z square equal to z into z bar. That is why we have done, and let's just multiply, simplify this. K equal to 0 to n minus 1. So z1 into z1 bar plus omega into omega bar whole to the power k into z2 bar plus z1 bar z2 omega to the power k plus z1 z2 bar omega bar to the power k. So let's separate the summation one by one. First case, k equal to 0 to n minus 1 z1 into z1 bar, that is mod z square, mod z1 square here. So I am writing mod z1 square plus, here we are seeing that omega into omega bar, that is mod omega square, and as we know that every nth root of unity, its mod is coming 1. So we can write here that 1 into and z2 into z2 bar. So k equal to same as this first line, that is mod of z2 square, plus in the third term, this term, if we just verify properly k equal to 0 to n minus 1, we are seeing that z1 bar z2. So we are writing z1 bar z2, and if we apply k equal to 0, that is omega to the power 0 1, k equal to 1, that is omega, plus k equal to 2, that is omega square, up to omega to the power n minus 1, that is 1 plus omega square equal to omega plus omega to the power n minus 1. And everybody, as we know that sum of the nth root of unity is always 0, like for cube root of unity 1 plus omega square equal to 0. It is the same thing. In the same case for the last part. For the last part also it is the same case. So here also same thing. The sum of the omega is equal to 0. Therefore we can write this as this is 0 as well as last term is also 0. Therefore final answer is mod of z1 square into n plus mod of z2 square into n, that is n into mod of z1 square plus mod of z2 square. So everybody, what is the option. Let's see and verify. Option number here, it is the first option. It is the first option. Now let's go to the question number 2. Now in this question number 2, if 1 comma alpha square or alpha to the power n minus 1 are nth root of unity, same as this previous time, and I equal to 1 to n minus 1, 1 by 2 minus alpha to the power I. What is the value of this? Let's see. So, for the second sum, let's apply. Once again, nth root of unity, its mod value is always 1. Here we can write this as x to the power n minus 1 can be written as a factor, product of the factors of n terms, x minus 1, x minus alpha into x minus alpha square up to x minus alpha to the power n minus 1. So, if we cancel on the both side, that is in the left hand side, okay, I am writing details. X to the power n minus 1 can be written as x minus 1 into 1 plus x square up to x to the power n minus 1. So, if we go to the cancellation of these two, we are getting cancelled, and we are getting here what? That equal to, it means we can write here 1 plus x square up to x to the power n minus 1. Let us differentiate after taking the logarithm, because it is in the product form. Let's differentiate after taking the logarithm on the both side. So let's proceed. 1 by, if we take the log m plus log n, and if we just differentiate, we are getting x minus alpha plus 1 by x minus alpha square plus like this 1 by x minus alpha to the power n minus 1, and the total part, if we take the log n just differentiate, we are getting here that a denominator is coming 1 plus x square up to x to the power n minus 1, and numerator is coming 1 plus 2x plus 3x square, like that, n minus 1 into x to the power n minus 2. So put x equal to 2, because our requirement is this. Therefore, we are putting here 1 by 2 minus alpha plus 1 by 2 minus alpha square dot 1 by 2 minus alpha to the power n minus 1 equal to, just put 1 plus 2 into 2 plus 3 into 2 square up to n minus 1 into 2 to the power n minus 2. So this is nothing but, and denominator is as it is, 1 plus 2 square is the denominator is a GP formula, 1 plus 2 square up to 2 to the power n minus 1, and numerator is the arithmetic or geometric series. Therefore, we can write here numerator is r equal to 1 to n minus 1. So we have done number of such sum in AMG APGP method. So 2 to the power r minus 1, and denominator is nothing but the first term is 1 and common ratio is 2, and total number of term is n. Therefore, this is coming to be a into r to the power n minus 1 by r minus 1. Therefore, it is coming 2 to the power n minus 1, and numerator using the formula sequence and series formula, we are getting 2 to the power n minus 1 plus 1 by 2 to the power n minus 1. So, is there any option here? So, what is coming here? N minus 2 into 2 to the power n minus 1 by 2 to the power n minus 1. So, plus 1 is where? Is the first option. Is the first option. Now, let's go to the third question. If 1 comma omega square up to omega to the power n minus 1 are nth root of unity, then 1 minus omega into 1 minus omega square dot up to 1 minus omega to the power n minus 1, what is the value? So, we are writing here that x minus omega into x minus omega square up to x minus omega to the power n minus 1 equal to 1 plus x square, because for the first what we had done, that x to the power n minus 1 equal to x1 minus x minus 1 into x minus omega. This step which has been used here, I have used this step, and I have cancelled x minus 1 on the both side. So put here x equal to 1, we are getting 1 minus omega into 1 minus omega square dot 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 up to 1 minus omega to the power n minus 1 equal to 1 plus up to n times, that is coming to be n. So let's see, the correct option is the C. Now we'll solve one more sum, and it is very interesting sum which came in IIT examination. Let S is the intersection of three set where S1 set is mod z less than 4, S2 set, it seems it is a circle, S2 its imaginary portion is greater than 0, and S3 is this, and S is the intersection of common to the three region is S. So let's get the S. After that we'll start solving the sum. First of all, from S1 is what? That mod z, it means root over x square plus y square, it means it is less than 4, so x square plus y square less than 16, it means it is within a circle. And the second case, that is imaginary portion of this part is greater than 0, so let us solve here the imaginary part. So we can write this as, in this case, z minus 1 plus I root 3 total divided by 1 minus root 3i. So ready, z equal to x plus I by, and its imaginary part we need, therefore we can write here minus 1 plus I root 3 total divided by 1 minus I root 3. So if we rationalize this, we are getting x plus I root 3 iy minus 1 plus I root 3 into 1 plus I root 3. Let us rationalize the denominator. So 1 minus I root 3 into 1 plus I root 3. So we need to get the imaginary part only. We don't need so much calculations. So if we just calculate here, we are writing just x minus 1 plus I into y minus y plus root 3 into 1 plus I root 3 total divided by a square minus b square, so 1 plus 3. So denominator is not so much important because we need the imaginary part. Now just see one thing, to get the imaginary part only, just multiply 1 with this imaginary portion plus root 3 with this x minus 1, this portion only we need. Therefore the imaginary part should be, here it is, x minus 1 into root 3 plus y plus root 3 should be greater than 0. Therefore y plus root 3x should be greater than 0. So y equal to minus mx. Slope is the negative. So everyone, what is the common region? Let us draw first. So let's draw one axis. Okay, I am drawing in some other place. And where we are getting y equal to mx, so y equal to mx is this, slope is negative, and we need the common intersection. It means, one more thing I forgot to tell, that is the real z greater than 0, so S3 is x should be, what is given here, x is greater than 0, it means positive x. So S1, S2, S3, the common intersection is this part. All the points which is here is the common intersection. Now let's proceed. Once again I am drawing the same diagram so that it becomes easier for us to calculate. Now let's go to the first question. Question number 1. It is saying that you have to find the area of the region. What is the area of the region? So for getting the area of the region, let's see this area is this angle. We need this area. This angle is coming to be 5 pi by 6. 5 pi by 6, and as we know that area of this part is any part of the circle such, we are getting area equal to half r square theta. So let us put here half r of the circle is here. What is given here? R of the circle, we got it, that is 4. So r square is 16. So here it is 16 into theta is 5 pi by 6, therefore which is coming to be 20 pi by 3. So let's see what is the final answer. What is the option? 20 pi by 3. B option is the correct option. Now let's do the question number 2. In this case, the question number 2 is given that minimum mod of 1 minus 3i minus z, where z is in the region S. So how to solve this thing? Let's see. Here in this case, for question number 2, what to do? Let us define again z minus 1 plus I into 3. So z is any point x comma y, its distance from 1 comma minus 3. So first of all we have to check whether the 1 comma minus 3 is this side or this side of the with respect to this line. First of all we have to check. It is better for us, for our knowledge it is very much needed. So in this case, suppose I am just doing in graph here. If we put, suppose it is 1 comma 0 here, suppose any point is 1 comma 0 here, 1 comma 0. If we put 1 comma 0 point on the line is what? Y plus root 3x. Y plus root 3x, the line. So if we put 1 comma 0 here, x is 1, y is 0. So this is root 3, positive. And if we put 1 comma minus 3, this point, if we could put 1 comma minus 3 here, we are getting what? X is 1 and y is minus 3. So obviously it is a negative. Therefore the point 1 comma minus 3 is here, this side. And everybody, so 1 comma minus 3 is here. This is coming 1 comma minus 3. So 3 square plus 9 plus 1, 10. So this is within the circle. Now we have to get the minimum value of this. It means we have to get the perpendicular distance. We have to get the perpendicular distance from 1 comma minus 3 to the line. This is the minimum distance. Perpendicular distance of 1 comma minus 3 to the line. That is our requirement. So let us solve it. This is the perpendicular distance is what? That is root over here root 3 minus 3. The perpendicular distance equal to by root over a square plus b square, 3 plus 1. So we are getting root 3 minus 3 by 2, that is 3 minus root 3 by 2. We are taking the mod value. So the option is what? 3 minus root 3 by 2. So the option number is C.